For projectile motion launched at an angle, we're going to have an object that is going to be thrown, of course, at a certain angle. Take a look at the picture right here. So we have this canyon right here, okay? And it's going to throw this cannonball. This is the target. The distance between the cannon and the target is 10 meters. In between, you have David over there, right? Okay, now take a look. At what angle is the ball being thrown? At what angle is it being thrown?
45 degrees.
45 degrees. Okay, so as you can see, for this kind of exercises, you're gonna have the angle could be 45, could be 6, any degrees, okay? But the path that the ball or the object is going to follow is always gonna be like a parabola. Take a look right here to the path that it follows, okay? It begins here. How do I know it's a parabola, for example? I know this is a parabola because if I measure point against any point, for example, this point right here is the highest position, for example, and what you have see here is the motion of the object when it's going upward and forward at the same time. And from that moment, from the highest point, it begins to come down, okay? So if you measure, for example, the velocity in this point right here and the velocity in the same point right here, they're going to be the exact same. The only difference is that here the velocity is going to be negative because it's going down, and here the velocity will be positive because it's going up. That's why it is a parabola, because for every point, you're going to have the same value in the velocities, for example, but it's going to be different in the sign, because this kind of motion, the object is going upward, and this kind of motion, the object is coming down. Sorry, Belen?
Please, so that sorry, that path in which the ball is going like down, it's named a parabola.
The whole path is a parabola. Have you already learned how to graph parabolas in math? Have you already, have you already learned how to graph an equation of second degree equation? Okay, when you graph it, you form a parabola. For example, the graph x equals y equals x squared. So what you're going to have is a parabola that is going to be more or less like this. In one side of the equation, of the graph, the other side of the graph. It is a parabola. It's known as a parabola because if you measure at the same point, for example here and here, if you measure at the same point, you're going to have the same velocity, but one of these sides is located in the positive side of x and in the other one is located in the negative side of x. It's a parabola, more or less the same, but instead of having this shape, it's going down like this. The parabolas in here in this kind of motion. That's why I was asking you if you already learned how to graph, because it's easier when you already know. Because at least it makes sense to you. Now, it doesn't need to be precise like in math, for example. You need to draw it exactly the way it is. Remember, in physics, everything that we do is just a sketch that shows the path of the object and where you put all the information that you know so far, and that is going to help you to visualize how the object is behaving. But in the end, it doesn't need to be precise. Now, what is the difference from this topic and the one from Monday? The one from Monday, it is not being thrown from an angle. It is the object that is coming in this direction, and then it begins to fall down. But here, it begins from the floor, what that's saying, from the floor, at a certain angle, continues with the path, and then it goes down to the same position that it was. Now take a look here. It says, use components to analyze objects launched at an angle. The components are the two parts that make up the vector, the x part and the y part. Remember, in vectors, I ask you, get the x component, get the y component. You're going to be doing the same here, but instead of having a vector, you're going to have an object. So you will have to draw the vector and use the components. So suppose the initial velocity of a vector makes an angle with the horizontal. Now you see right here, okay? It makes an angle, and this angle is measured from the x-axis, from the horizontal axis. Again, to analyze the motion of such a projectile, you must resolve the initial velocity vector, okay? So initially, the first step in this kind of exercises, initially what we're going to be doing is getting the components of your initial velocity. From that, you can continue with the rest. Now, how do you get the components of the initial velocity? Remember the sine and cosine functions. They can be used to find horizontal and vertical components. So, to find the x component of the initial velocity, you will be using cosine, and to find the vertical component of the initial velocity, you will be using sine. For this kind of exercises, yes, it will be mandatory that for x, you're going to be using cosine, and for y, you're going to be using sine. Because in all the exercises are going to be thrown at an angle according to the x-axis. Now, sometimes I could be really evil and put it according to the y-axis, but I don't think so. I mean, I like you, so I think I'm not gonna do such thing. Or who knows? Maybe you'll be prepared. I mean, it's true. I can give you the angle according to the y-axis, and it's going to change everything. And that's why I told you from the beginning, we care about the position of the angle. So maybe for the majority of the exercise, these are the two formulas that we are going to be using. But it doesn't mean that it's 100% right. Sometimes we're going to be using the other trigonometric functions. I mean, for x, we could be using sine, and for y, we could be using cosine according to the position of the angle. It will depend, always will depend from the position of the angle. Are you having troubles by seeing my presentation? Or it looks okay?
Looks okay, Miss.
Okay. Now, take a look at the bunch of formulas that you have over there. That's why I told you the other day, you need index cards to write down the formulas. Yes, you will need them. So, the formulas that are in the blue part are those that appear in your textbook. Okay? Now, I like to arrange it differently. So, take a look to my formulas here. For the initial component, that's the first step in this kind of problems. You need to get the components of the initial velocity. So, this is how you get it. For x, cosine, for y, sine. Remember, the initial velocity in x is gonna be the final velocity in x because it remains constant. That is a condition for this kind of problems. To get displacement, this is the equation. To get the displacement in x, it is Vix times delta t. But you can get it directly applying this formula. To get the initial velocity in y, it's initial velocity sine of the angle. Just like we have here, okay? Now, what if you need to get a final velocity? Well, this is the equation that you should be using. It will be the initial velocity in the y component plus gravity time. This equation, this one right here, you need to get the square root to have the final velocity in y in case that you don't have the time. This one is used in case that you don't have the time, okay? So if you don't have the time, this is the one that you must use, but you need to get a square root of it. Now to get the change in position in the vertical axis, this is the equation, initial velocity time times 0.5 gravity time to the second power. All these equations are coming from kinematic equations, but they are adapted for 2 dimensions. That's why it looks so big. But in the end, it's quite the same. The only formulas that are quite different are these 4, okay? But they come out also from kinematics. These are special formulas that I already isolated for you. So, y max. What is y max? It is the highest point in the parabola. So imagine this is the parabola. Y max is gonna be right here at the highest point. So how do you get the highest point? Could be x max or y max. I like to call it y max. Okay? You get it? If you know the initial component of in y, raise it to the second power and then divide by twice the gravity. Now, x max refers to a change in position horizontal, but the maximum point, the maximum distance that an object can have in this kind of exercise. So take a look here. If I want to get the x max, is gonna be the largest distance of the parabola, which is this one, okay? All the horizontal distance. This will be x max. Now, ty max is the time it takes for the object to reach the maximum height. So, imagine that it says that a ball is being thrown, okay, from here to the highest point. And then they are asking you, how much time did it take to reach the highest point? Then you will be using this equation. But this equation is not so important, honestly. It is important because it can help you to calculate the time in the air. The time in the air, is the time that it takes to do that total path, the total flight time, okay? So, if I want to know that time in air will be the time that it takes for the ball right from the moment it comes from the ground to the moment it reaches again the ground. So for the full path, to know the time that it takes for an object to make a full path, it's going to be the time in air. Now take a look to that image over there. Projection at an angle. Take a look. This is the ball. Okay? So, of course, he's going to hit the ball. That's the purpose of golf, you know. He's going to hit the ball, and what happens? Because that ball is going to be hit at a certain angle from the floor, means that in every point, this ball is going to be having components. Take a look. Here you have the components y, x, y, x. As you can see, when the object is approaching to the highest point, the velocity in y is being decreased. Take a look. Here we have a higher velocity, smaller, a tiny velocity, and here none, nothing. Okay? The reason is because in this point, the object stops moving in the y-axis for a fraction of a second. When you throw an object in the air, you see, like, as I told you, in a fraction of a second, the object stops moving. And then it begins moving down. But in this point, in the highest point, the velocity in y is 0. Because, as I told you, for a fraction of a second, the object stops moving, at least vertically. And then it begins the negative velocity, because it's coming down, and it's coming down at a higher velocity. That's why, I don't know if you have heard about las balas perdidas. Okay, that is a common sad story here in our country, because we are a developing country, and what can I say? People like to celebrate with guns. I don't know what they have in mind, but they like it. So what happens? What is the physics behind that kind of celebration? So a random person takes a gun and begins to shoot to the air. Okay, so the bullet comes out from the gun at a really high speed. Okay, remember, projectile motion is a parabola. Take a look to this picture here, and that's why this is so important. I want you to see this. I will highlight in yellow because it's ugly, the yellow. Take a look. The initial velocity in y and the final velocity in y, they are the exact same. They have the same size, but they have different directions. That means that when the ball finally goes down to the initial vertical position, it goes with the same velocity that it had initially. So, when someone celebrates with a gun, the bullet, when it goes down, it goes exactly at the same velocity it was shot. And that's why people get killed. At a certain point, the bullet will stop moving upward because of gravity. Yeah, gravity, it's kind of guilty. But in the end, if you wouldn't take that not very smart decision, that wouldn't happen. So, celebrating with guns is not the safest thing to do, It's nothing wise in it, and randomly it could kill someone. That's the physics behind it. And that's why I'm always against guns. But anyway, that is just my personal point of view. So, directions are indicated by signs, but I want you to also take a look to this. This is going to be in green. Take a look to the initial velocity in x. What happened in x? How do you see this velocity? Does it change? Or is kept the same?
The same.
It is kept the same. Okay? That's why in the formulas that I gave you, I say initial velocity in x equals the final velocity in x. Here, with this parabola, you can visualize it. It is a very interesting topic, and also, in my opinion, is one of the hardest to learn. But it's amazing. I just love it. To be honest, I just love it. When I was your age, I didn't. I totally hated it because I didn't get all the points in an exam because of that topic. But in the end, it is important. And sometimes you just need to analyze what the book is giving you. Maybe the teacher doesn't have to tell you everything, but everything is in your textbook. So, years after, when I took my textbook and I read, like analyzing what I was reading, I don't know, my mind just got open with that. So remember the path that the objects follow. Vertically, initially it begins with a really high speed, and it's going. It's the final velocity is going to be the same as the initial velocity, but as long as the object is going up, the velocity in y is being reduced because of gravity, and then after it passes the middle point for that chain, which is the highest point in the parabola, the velocity in y becomes negative because it's coming down. Okay, the object will be coming down, and when it reaches the ground, has the same initial uh, velocity that it had initial at the beginning in the y-axis. In x, remains constant at all times. Now, I don't know why I wrote this. Because in the end, this is everything that I say in the videos, okay? Okay, so here, in the general case of projectile motion, this involves an object that is projected at an arbitrary angle relative to the horizontal. Because it is relative to the horizontal, I gave you the formulas I gave you already, okay? As I told you, I could be evil and put the angle according to the vertical axis, but that's not precisely my point. During projectile motion, the object travels up and down while traveling horizontally. So, the object goes up, is moving vertically, but it's also traveling horizontally. It is motion in 2 dimensions. Okay? So the curve described, or the path of motion, or the trajectory of the object, is called a parabola. The path of a projectile motion is often referred as parabolic arc. Now, in the case of horizontal projection, time is the common feature shared by the components of motion. Now, here, we're going to be using the range R. The range R is just another way to say the maximum horizontal distance. When I say the maximum horizontal distance, remember from the formulas that I gave you is the X max. X max is known as range or maximum horizontal distance. And here you can see the parabolas that could be projected by the same object thrown at a different angle. So if you throw this object at an angle of 15 degrees, you can see it doesn't reaches the maximum range that it could reach. At what angle the object moves or covers more distance, horizontal distance?
At 45 degrees.
At 45 degrees. So that's why in some sports, okay, the players need to reach the angle of the 45 degrees, like in golf, um, to assure that the ball is going to cover the most distance possible that it could. Some other times, the golf player could use a different angle. I mean, I know nobody's gonna keep a protractor to measure the angle. That would be dumb. No, that would be very smart, but not so convenient. It will be ridiculous on TV. Imagine someone measuring the angle like that. But that's why they practice, That's why they practice. They record themselves practicing and seeing what they can improve. When you record something, you can actually measure the angle, but not while you are doing it. That would be very weird. But in case that a person has more experience, well, they will know what angle to use according to the situation. For example, in a sandbank, a person probably will need to use an angle of 60 or 75 degrees, but it will depend, okay? I don't an expertise in golf. That's so boring for me. And well, I'm not. I'm just gave you. I just gave you that theory. I'm gonna recommend to watch one of my explanations. So that will be the homework for this week. Okay, I will assign a problem. Well, not a problem, different problems for horizontal projectile motion. That is the topic from Monday. And from this topic, you are going to watch one exercise. The idea of watching the exercise is that for Monday, you're going to be more prepared in this topic so I can do a larger exercise and record it in class. Of course, you're going to be working with me with that exercise. Now, I'm going to share with you the link of this video. And you're going to watch it as a homework, okay? When you finish watching, you have to write it down in your notebook. Not while you are watching. I mean, I give you the instructions and you're probably going to do whatever you want because I'm not going to be there to check. But I totally recommend to watch the video without doing anything at all. Just watch it. After you finish, you begin to write down the problem with the video if you want. But the first time you watch it, please be totally focused on it. So I'm going to be sharing with you the link. I didn't send it. It's right here. Watch it as a part of the homework. And I'm going to assign exercises from horizontal. Now, I'm going to be sending you a link, a Google Form link, tomorrow afternoon, okay? Tomorrow afternoon, I'm going to send you a Google Form link just to ask you a few concepts from the two presentations of projectile motion, okay? From the one from Monday and the one from today. Just what I consider to be the key concepts. Come on, my theory quizzes are very nice. And you know my true or false is always, let's see if you remember.
always false.
It's always false, and I don't know why people put it like if it was true. I mean, they never trust me, and it's always false, and but they never trust me. It's funny. Okay, guys. You can start watching the video and write the exercise in your notebook. As I told you, I'm gonna assign you a homework, 4 exercises about horizontal projectile motion, 4 or 5, I think. So have a great weekend, everyone. If you have doubts in chemistry or physics, I'll be tomorrow in the afternoon free, okay? Not today. Today I won't have electricity. Goodbye, guys.